In this lecture, we will discuss about Dalton's law of partial pressure. Let us say we have a vessel and this vessel contains different kind of gases. Let us say this vessel has N1 moles, that is moles of component 1, moles of gas 1. Similarly, I have N2, that is moles of gas 2. I can have N3 moles, that is moles of gas 3. Similarly, we can have many gases and moles are corresponding N1, N2, N3, N4, N5. So these are the moles. So this gaseous system, this vessel contains N1 moles of gas 1 and this contains N2 moles of gas 2 and 3 moles of gas 3. Similarly, it can have more moles of gases. We can define partial pressure, let us say partial pressure of gas 1, and in short it is written as P1, and this is the meaning is pressure due to gas 1. So let us say if I have this vessel, all molecules are colliding with the wall and separately this type of molecule is exerting a different kind of pressure, this molecule applying a different pressure, this molecule is applying different pressure. So P1 is the pressure due to gas 1. Similarly, we can have partial pressure of gas 2 and this will be P2 and that is pressure due to gas 2. Similarly, we can write P3, P4, P5. So P3 is partial pressure of due to gas 3. Basically, we can calculate P1, P2, P3 value using ideal gas equation. So if I have ideal gas equation, I can write the same equation for pressure, that is nRT by V. Now if I am interested in partial pressure of ith gas, I have to consider mole of ith gas into R into T divided by volume. So 2 point is important. So we have pressure due to ith, this is the partial pressure, due to ith gas, and I have number of moles, that is moles of ith component or moles of ith gas. But the volume, the denominator volume is, this is the total volume, so this is important. So total volume, let us say this vessel has a volume of V, so we can write partial pressure due to 1, P1 is equals to N1 RT divided by volume V. Why we are writing volume V total? Because any gas, this gas is free to move inside this vessel anywhere. So volume occupied by any one of the gases is V. Similarly, I can write P2, this is nothing but N2R T by V. Similarly, I can write P3, this is N3 RT by V. If I have more gases, we can write the same equation. If I add now, so if I add all this, we will have P1 plus P2 plus P3 and this will go on, and this is equals to N1 RT by V plus N2 RT by V plus N3 RT by V. Now if I take common RT by V, so I will have N1 plus N2 plus, and this goes on, plus N3 RT by V. Now let us say this equation we have Call this as equation number 1. Now in this gaseous system, I can also apply PV is equals to nRT as a whole. So what is the total number of mole in this system? So total moles in vessel, and this is nothing but N1 plus N2 plus N3, and this goes on, and we can apply PV is equals to nRT as a whole. So we can apply PV is equals to nRT in gaseous vessel, as a whole. So if I apply PV is equals to nRT, so let us say P total, and V is volume, and number of mole will be N1 R, N1 N2 plus N3, and this goes on, times RT. So we can from here write P total is equals to N1 plus N2 plus N3 into RT divided by volume. Let us call this equation 2. Now if you see equation 1, right side of the equation 1 is same as right side of the equation 2. So RHS of equation 1 is same as RHS of equation 2. This means left side has to be equal. P1 P2 plus P3 is equals to P total. So we can write P1 plus P2 plus P3, and this is equals to P total, or I can write P total is equals to P1 plus P2 plus P3, and this is called Dalton's law. Dalton's law of partial pressure. What is the meaning for this law? Meaning is total pressure inside a vessel is equals to sum of the partial pressure of each gases. So I can write total pressure in a vessel is sum of the partial pressure. Important point we have, these gases are basically not reacting to any one of the gases. So gases are not reacting, let us say component 1 and component 2, they does not have any kind of chemical reaction. So we can say this is valid when there is, so assumption we should have, that is there is no chemical reaction, between any one of the gases, So we can basically calculate partial pressure, and then we can add to get the total pressure. So if I summarize, so this is nothing but sum of the partial pressure is equals to, I goes from 1 to n, and this is equals to P total. So we can basically calculate each partial pressure, and then we can add to get the total pressure. So this is the Dalton's law of partial pressure. That is sum of the partial pressures is equals to total pressure. An important point we have, gases are not reacting to each other.